Can you guys hear me? Yeah. Oh, great. So how's the lunch so far and the post-lunch sessions? Hopefully they're good. So let's try to resonate that over here. Thank you for the opportunity to be here on behalf of Global Foundries and myself. Let's make this an interactive session. I think it's a wonderful segue that Vivek arranged to have me go after Michael, because what I'll try to do is the things that Michael talked about, if they're important enough, I'll try to blend them into what I actually did at Qualcomm with this product and what we are trying to do now at Global Foundries. So when I got this invitation, I was with Qualcomm, and Qualcomm Life in particular. I was with Qualcomm for 18 years. And the last 6 years at Qualcomm, I was focused on the healthcare life sciences space. I was the senior director for product management there. And while we were in this space, we got the opportunity to actually make a funding pitch and a business plan pitch to our CEOs because they wanted to go into adjacent verticals. And so it was along the same lines as what Michael was describing, and I'll take you through that. And what happened. So my topic today is give you an insight into how we brought this product to market, which is fully commercial now for the last 4 years almost, and how we moved the smarts which are in this product, which is a plug-in-the-wall gateway called TuneIt, onto your smartphone. And both are gateways that actually capture medical data in your home and get it to the providers of the systems that need to use it. The next part of my conversation after that is I'm going to give you a little introduction on what Global Foundries is all about and what the semiconductor landscape is, and then take you for a tour of what is the Internet of Things. People familiar with that term? Have heard about it, right? A lot of things there. But what is the significance of semiconductors, and why is it so important to what is happening with the Internet of Things and what the numbers there really mean? And what does it mean specifically bringing it around to healthcare and life sciences, because I think that's really important. So these are the 3 things that we'll talk about. And what I do at Global Foundries now is I'm the vice president for driving the Internet of Things on the product and the business strategy side. It's based out of Santa Clara and Silicon Valley. So I go back and forth between San Diego and Santa Clara. But let's start. And so, as we are getting into this conversation, interrupt, stop, ask questions, because if you have a question at the moment, it's good to talk about it right then and there, or we can hold it towards the end, no problem, okay? In general, this is a chart that I've used frequently from HIMSS. HIMSS is a very big organization in the healthcare space, a trade alliance, and this is their representation of what a mHealth ecosystem looks like. This picture is about 6 or 7 years old, but I still use it in any of these kinds of presentations because I think it captures the essence of having the patient in the middle and the patient as a consumer, because the patient is consuming the devices and the data around it onto themselves and providing data out and to take care of their health care. So it's an ecosystem which is built around the patient, and I think it's very central to remembering that because it's all about the patient ultimately. I'll take you through some of the primary stages in a product commercialization process, and then I'll apply it to how we actually put it together for bringing TuneIt to market and tied back to Michael's presentation. Folks familiar with this product development life cycle? Anything similar to that, where you take a concept, you have an idea, you define what the concept is, you build the requirements for the concept, and then you take it to market and launch it. Folks have done that or aspire to do that? I love the energy. That's good. I love the enthusiasm. Okay, so let's talk about that. Typical product life cycles, there's been a lot of books written about it. There's a lot of stuff around it. What's going on now is what's called the lean playbook or the lean way of doing things, but it's in essence what they mean is you have a concept, you have an idea, you think about it, you refine it, you do business development around it, you try to validate it, you actually identify what you want to do with it, then you create a design for it, you develop it, you actually engineer it, manufacture it, build it, and then you launch it. You put it out there in the world, and then let people use it or let industry use it. And then you need to go into what's called an operational cycle, because once you have launched something and you're passionate about it, you need to maintain it, you need to sustain it. And that's what a typical life cycle is all about. The same thing applies to mHealth. When you bring an mHealth product to market, whether it's a medtech product or something for a healthcare system or something for big pharma, it follows something along these lines, where there's a concept phase leading up to a design, development, integration, testing, certification, manufacturing, ops, and support. One of the key differences, which I think the gentleman over there asked the question, was around, what it was. I'll raise it up to a level, which was, his question was around FDA, but broadly, it applies to controls in the system. Because you need to, for healthcare products, what is the primary function of the FDA? Anybody can say that? One word. What are they there to do? Safety. Safety, right? That's exactly it. They want to be sure that whatever is put out in the healthcare space is safe. For who? For us, right? That's what they're there for. So their lens is the safety lens that they're going to look at everything for. Then, tied to that are elements of quality as well as controls. What happens when something goes wrong? How do you pull that something back from the market? That's called a recall. It's a bad word sometimes, but it's done for the right purposes, which is, again, tied back to safety. What is the quality of the product? You spend something to buy a product, you want to be sure that it's of good quality, especially when it ties to your healthcare. You want the medical device reading, your blood pressure, when you take the reading, you want it to be correct, right? When a doctor presents a diagnosis of what they've done based on the data that was collected from medical devices, they're basing their decision outcomes, actionable outcomes, based on the data that they collected from devices or the environment or what they gauged from you. So that has to be correct and rightful. That's what quality is about. One of the two big elements which has now come into multiple industries is security and privacy, right? In a way, you can think of security and privacy are two sides of one coin, but they're different in a way, right? When a security breach happens at a particular location, what can you do about it? What typically gets done when a security breach happens? You let it breach, continue, or what happens? What do you do? Fix it, right? Therein lies the importance of security. You can fix it. It's controllable, right? With privacy, it's different. With privacy, if something gets out there, as we have heard recently, there have been tremendous amounts of scandals around privacy and data breaches, et cetera. When it's out there, it's out there. It's difficult to pull it back in. Now think of what are elements in your life as it relates to commerce or your personal life which you want to be the most secure? Something related to, what's that? Credit card, or what you spend, money, finance, right? Payment card industry controls.
If you have a mental illness, you probably don't want that out there.
Healthcare, right?
Well, particularly mental illnesses or addictions.
Correct. Or anything related to slander, right? Reputation. These are things that you would fiercely protect about yourselves, right? They are very important, especially when they apply to you or your family. That's why there's so much work now being done around security and privacy. And as we get new devices that come in that connect you, or through social media that get you connected to the world, it's, again, think twice. There are controls. And unfortunately, what's happened with all these industries is, while they're given greater power to the consumer, they're given greater responsibility to the consumer too. Because you're responsible for seeing that your laptop at home has all the right antivirus software loaded so you're secure, your identity is safe. The data which you give out to somebody is managed appropriately because it's ultimately your data. So therein lies a challenge there that has to be managed. So if we bring it back now to healthcare, to make a good healthcare product, there are a lot of processes and controls that are kept in place, and they're tried to tie back to some sort of a standard when you build that product. Healthcare is one of the most fragmented industries out there, unfortunately. There's no universal standard that governs end-to-end, thou shall release a healthcare system like this. When I was doing my master's in biomed engineering, when I was bringing this product to market, one of our professors was, I think, a doctor from Johns Hopkins, and he put it rightfully. He said, you know what, healthcare isn't a system. It's a bunch of things that came together and we now call it a system. And that's true. It's in the United States. It's in all the countries. There's some, and it's huge, right? When things are complex and huge, it's difficult to manage it. We have seen challenges with the system related to EMR and you know, taking your longitudinal data when you go from doctor A, B, or system A, B to C. The continuity is not maintained. Usually when you end up in an emergency room or you go to the doctor, they spend the first 3 minutes, no matter how sick you are, to ask you, what's wrong with you? What happened? You're like, I'm part of your system. Am I not in your EMR? Yeah, but just tell me. Because it's easier, faster, quicker, sooner to do this, right? Because most probably the system isn't connected. And it's not their fault. It's just that there's challenges in making all these administrative systems tie together. But we live in that world. And that's why standards are important. There's no universal standard today for healthcare, but there are governing standards today for quality control processes. So ISO 9001 is for universal quality control as it relates to good practices in industry. ISO 13485 is tied specifically to the healthcare industry. So when we started in Qualcomm to bring this product to market, the first thing we did is we didn't start building. We started looking at this quality standard. Because the challenge with these standards is when you build a product that you want to be approved through the FDA or the European CE organization, et cetera, your quality controls have to be in place first, and then you build to the quality standard. You cannot build a product and then apply the quality standard because your product has already been built. It has to go through the rigor. So we had to do our homework when we started. That was around this phase where we did requirements and product definition. Now, let me flip over to what we actually built, and then I'll tie it to, let's introduce this slide. These are some of the other variables that are there in manufacturing a healthcare product. And I'll come back to this slide in a little bit. I wanted to show you what we built. So this is the end-to-end use case scenario of what, this is almost the first picture that I drew on the whiteboard when we started, what we envisioned to be this product. This was supposed to be, we wanted it to be a nightlight. We said, make it like a nightlight. It sits somewhere in the wall, plugged into your home. It passively is connecting data, measurements from any medical device that you're using to monitor vital signs over different technologies. It collects it, and then it sends it over a cellular connection to the cloud, to our partners and customers. From there, disseminates it to whoever needs to get the data, whether it's their healthcare system or medtech providers or big pharma. This is the end-to-end system that we created. The different kinds of medical readings that it can take are like blood pressure readings, diabetes-based readings for your blood glucose level measurements, your fitness, activity, everything that ties back to a chronic healthcare or chronic disease management condition. So that's what this little thing was supposed to do. And we wanted it to be non-intrusive. We wanted it to be something that can easily fit in the home. But where did we start, right? So we didn't have this in mind when we started. We said, what do we want to solve? Which is, again, going back to what Michael was saying. What is the problem you're trying to solve, right? So we said we needed something simple that's easy to use. One instruction, open from box, plug in the wall. It then starts up by itself, self-configures, connects back to the gateway, knows who I am, and it's ready to go from that point on. It should be as simple as that. It should be targeted to a particular set of people, right? There's such a huge population in the world. Which population does this product serve? So that's typically called what we call segmentation of the industry. One is segmentation of the product, one is segmentation of the target customers that you want to reach. So there's different customers that if we separate it by demographics for age, you could say the 0 to 30, 30 to 50, 50 to 80 and beyond. That's one way to segment the population. This is roughly what we did. And we did a lot of analysis of surveys, talking to a lot of partners, and that ties back to what Michael was saying, which is the business development piece. We had a rough idea, we wanted to build something because we had some IP around this, that we could build a gateway plug in the wall. But where do we target it and what are we actually going to build? The one thing that I'll add to what he said was, you need to validate the essence of the product that you wish to bring to market. If ideas are cool. They're a million all over the place. Bringing the idea to market to hit the right tangents and making money off of it, if it's a commercial enterprise, is a whole different story. And I think that's what's important. Once you bring an idea, you think about it, you define it, you have to validate it for somehow in the industry, whether it's called business development or it's called surveying or it's called talking to people, but somehow gauge inputs back that yes, this is valid, this can have legs on its own. We did that. We did that for about almost a year. And around that year, we then decided, look, if it's a product like this, which is going to sit in the home, should we go by technology or should we go by age groups? We then decided, no, let's not do that because it was a little bit too confusing. We decided to go by behavior. If there's an elder at home who is trying to manage a chronic disease condition, usually what happens is when you have one chronic disease condition like hypertension, over time, it leads to what's called comorbidity. That means you can get another chronic disease condition, which is as a result of proclivity to the first one. So then you end up over a lifetime having to manage more than one chronic disease condition. And these chronic disease conditions, the way they're managed at home with healthcare devices they're devices that take some medical readings. The behavior that's exhibited by all of us, usually at home, is your devices are in a room somewhere. The device doesn't come to you. You go to that device to take your reading at the particular time of day. Just like when it's time to take our meds, we go to the medicine cabinet to take our meds. There's a behavior tied to it to comply with the behavior to manage your health care. So we said, okay, if these devices are going to be stationed in a room somewhere, then that room needs to have this plugged in the room so we can collect the data over some sort of a radio like Bluetooth or Wi-Fi once the medical device reading is taken. Fine. Now we got the data from the medical device to the hub. Now how do I get it to the doctor? Okay, well, these technologies they're within your home. They don't let you get the data out. So then we decided to go, okay, let's put cellular as a connection in there to get the data out to the cloud and move it from that point on. But we again segmented the population down, saying we're not going to go with the entire population base. We're going to target the 65 and above because that was the baby boomer generation which was coming out with a lot of chronic disease management conditions that we were targeting. But we kept a back door, and the back door was we're going to release this product targeted at that segment. Our roadmap for product development was we're going to build another product which needs to take the smarts of this product and then be able to incorporate it for the other segments of the population we didn't consider, like the upwardly mobile, people who have some sort of a smartphone. Who doesn't have a phone here? There you go. So that was a quick litmus test that we did, that everybody is going to have some sort of a smartphone, right? And we already built the smarts here. So what we did is, how can we reduce the time to have to rebuild all the smarts here to get it into your smartphone? We chose the guts of this product to be Android, because what we had seen in the market was that Android was the fastest evolving operating system for computing devices. So we knew that if we built the smarts, the software smarts in Android, we could then keep updating the software on this, plus we could take the software and move it to Android phone, and then we could create a variant of that for iPhones. So now we are expanding our breadth and reach into the market to get to customer, and we have a path in terms of a roadmap because we can do it over time. once this product is accepted in the market. So that's the channel and the pathway that we followed to gradually build this product up and get it to the market. And we started, then we were thinking of who are going to be our customers, who are going to pay us. So then we again segmented the population in terms of 3 areas: the medtech, the medical technology OEMs, the device manufacturers, the people who actually make medical devices, like the Nonins of the world or the Medtronics of the world, healthcare systems, UCLA Healthcare, UCSD Healthcare, Stanford, Kaiser. Okay. The third one was big pharma, because big pharma is central to one of the biggest issues related to chronic healthcare management. When you have a chronic health condition, you usually take some sort of a pill to manage the health condition, or more than one pill to manage the healthcare condition. Medication adherence or compliance to take the medication is one of the biggest problems in the United States and the world. It's a $30 billion plus problem, if you want to think about it in numbers. But what basically it means is when people start feeling better, they stop taking their meds. They stop taking the meds, after a little while, things are good, and then the problem comes back. Now they need to go back to the whole regimen and take more meds, or it could have led to something else. That's why pharma was important, because we wanted to be sure that medication adherence is a problem that we are solving through this case by just simple monitoring of what the person is doing and taking their medications or not. So these are the different challenges in terms of what we want to do in the market, the problems we want to address, the issues that we want to be solving that we were focused on. The technology was I'm making this oversimplistic, but it was the easier part. It was, bringing it out to the right segment of the population was the challenge, where we spent a lot more time and homework doing this. We ultimately released this as a Class 1 FDA-approved medical device. We put a tremendous amount of controls in our cloud. We built a private cloud. It had what's called HIPAA-level security checklist controls. On top of that, one of the most stringent controls in the world is tied to your payment card or your credit card information management. That's called PCI, payment card industry. The level of controls in that case are pretty significant. Like when you go into a PCI room, there's special personnel who are trained to handle the data. There's usually physical and logical controls, cameras, man traps sometimes, automatically locking doors. The physical racks where your servers are housed, they're usually cameras that focus on those racks, and anybody who shouldn't be near that area immediately gets locked upon and security comes in, because the data for that person is traveling through those systems. So that's why you had to harden all those things, and therein lies the importance of this, because the key currency that we are transmitting across this whole thing is the data. It's the user's medical measurement that will become very important, because it goes and gets tied back to the medical record of the person. So that was the value proposition that we were building out for this entire system. The technology was there, but the value was, how do we collect the data in a secure fashion, and how do we guard it from a privacy and safety standpoint? That make sense, guys? Any questions till here? Yes. Yeah.
How about the cost? The cost of that?
This one? When we built this to market, our goal was to keep it as sub $100 retail. The way it works is it has a service plan associated with it. So once it gets plugged into your home, there's a $10 or so fee to manage the data every month, and then move it back into the cloud. I don't know what the current numbers are on this. This was when we actually built the system. But that number, the $100 number and the $10 was the range that, again, that was an analysis of the system that we did, of the market, that's what the market is ready to pay to bring in a healthcare monitoring system like this to bear. Yes?
How would someone incorporate additional sensors and capture that data? What would you need to do
Yeah, that's a great question. So I'll answer it in two ways. The sensors that we have segmented the sensors also based on the kind of medical devices that we're targeting. Bluetooth was a predominant sensor, this was 4 years ago, which was getting its real estate in almost all medical devices. But we knew that Bluetooth was transitioning to Bluetooth, what's called Bluetooth Low Energy or SMART today. So that was predominantly around medical devices. ANT Plus was a technology prevalent 4 years ago focused on the fitness devices. Now we're seeing that Bluetooth is entering the fitness domain pretty significantly. Wi-Fi was for the devices that are going from the hospital to the home. Majority of the devices in the hospital communicate over Wi-Fi. When you do remote healthcare monitoring of a patient in the home, if they take medical devices with them, they'll usually be Wi-Fi based. So we wanted to be able to communicate with those devices. We also kept a little USB in here. The reason for the USB was for what's called the legacy devices. There are a lot of wired devices out there, healthcare devices, which that install base is much larger than wireless devices. Those they traditionally were unconnected, then they became POTS line connected, then they became what's called RS-232, which became USB. So if you have a hardwired device, the USB was dual fold for either connecting the hardwired device or to add in an additional sensor through a USB stick for the ones that we didn't include over time. But that's one in terms of the radio technologies. In terms of the actual medical devices themselves, let's go back to the part of the discussion where I mentioned a disease condition. If you're monitoring hypertension, usually a blood pressure monitor is the one device that you'll have. If there's a comorbidity that came around and then you needed to add a glucometer to your measurement, and that needs to be added to this system, the way it works is the glucometer is just sent to the home of the patient. Once the glucometer turns on, then it gets registered with this device. It calls to the back end to determine if the glucometer is valid, and it just gets it back onto the system. So the consumer doesn't have to do any new work there. And that's how we can add new devices. And typically, if you look at the number of devices that are in a home to monitor healthcare conditions like this, they can range anywhere from 1 to 7 maximum. Beyond that, it's usually something which has to be hospital-based. So we can take more than those number of devices into the system. Yeah?
So you're monitoring all of this information, but in terms of patient outcomes and improvement of quality of life, has there been an improvement and more importantly, saving of money?
Yeah, there's actually a lot of studies, independent studies, third-party studies, which have been done in this space. And again, we are acting as a technology enabler to get the data out. We do not interpret the data. Like when we see a blood pressure reading of 150 over 90, we see the numbers. We do not interpret the numbers. It goes back here to the doctor, whoever, and they interpret the data just as we do in EMRs today. So if you just do a Google search right now on remote patient monitoring and outcomes and improvements, there have been a significant number of studies which have been done in terms of twofold. One is improvement in the outcomes. Usually the outcomes tie back to reduction in cost and reduction in hospitalization, because therein lies the major cost. So if you can catch a condition which is going critical early on, and you can get the person to go to their doctor sooner before the condition becomes elevated, then you may have just intervened at the right moment and saved a lot of healthcare costs downstream. Yeah?
So on the doctor side, so how often the doctor needs to review this data and analyze the data?
You guys are hitting on all the right questions, which is really good. So I guess I'm resonating right. You're right. So when we started this whole thing, a lot of other people have systems like this. What was interesting was doctors were saying we don't have the data. If we have data, we can make more informed decisions, right? Here you go. We've got a lot of data, and then it becomes too much data. Right? It's the other side of the spectrum. So the pendulum kind of swings this way and that way. You know, then you obviously have people who come in the middle. And then you have more intelligent systems that start coming up here, right? So there are systems like the enterprise systems which monitor the data or which is done to nurse case managers or others. It takes in and aggregates the data and then raises it up a level to something similar to what a traffic light scenario is, where red, yellow, and green. So that if a typical nurse case manager manages anywhere from 10 to 100 or more patients, it then aggregates and stratifies by the risk, the population, the data which is coming in, and then it raises up the patients who show up as red and yellow over green. And that's why they're able to then manage the data. And some healthcare provider systems, as well as private provider systems, they actually have a regular checklist scenario where they call the patient at least once a day or once in a week to check on them. And alarms are pretty prevalent in these systems. If somebody didn't take a reading or something was out of bounds, an alarm shows up at the monitoring site, and then they call the patient to mass, so they try to catch it early on. But you're right, data management is a challenge, but it's a twofold. Nobody has still figured out how to handle data analytics for medical healthcare to give great outcomes. So that we know that there's a vast amount of interest, whether it's healthcare data monitoring, genomics, contextual, otherwise, to collect the data. How do you bring all the data together, integrate it to make it an outcomeable thing? That's what a lot of folks are working on, including the monetization aspect of the data, which I think is critical. All right, so now I'm going to switch gears and take you into what Global Foundries is about. And the thought to keep in mind is, why are semiconductors so important to us in the world today? Tell me one device today that you use that doesn't have a chip in it, or a car that you drive that doesn't have a chip in it. The human mind is getting there. So it is important, and I hope to take you through why it's so significant. So in terms of what Global Foundries does, it's the second largest foundry. So anybody know what a foundry is? Or who doesn't know what a foundry is? Okay, cool. Foundry is where the chips get made. Okay, so the chip that you see when you open up your phone or you open up any device that you have, and you see all these little wires and the stuff connecting and the chips inside, the way that the chip gets actually manufactured is what's called a foundry. A foundry has these huge processes and manufacturing systems in place that take what's called silicon. And that's what is in the heart of chips today. When you see a chip, right, it's something touchy-feely tangible, right? But what went into making that chip is, therein lies the magic. There's a material more commonly known as sand, which has an element in it called silicon. And silicon has a property that and I'm going to oversimplify this, so all the semiconductor aficionados, please forgive me, but I'm trying to make it real here for everybody else. At the heart of all of our electronic devices is the ability to turn the device on and off, or make the current flow on and off. A breakthrough was made, I believe in the 1960s, by 3 people in Bell Labs who invented what's called a transistor. And that started the evolution of what led to Silicon Valley, which is something that is so small that can turn current on and off and make different things happen in a particular sequence. And that's led to what's called an integrated chip, which is what's now at the heart of a lot of the electronic devices. But the stuff that makes the magic happen in the chip to make the electrons flow and the current turn on and off is base material called silicon or germanium or argon, and there's a few of these materials out there. So think of it as a chip is something that you get in your hand, but the process of manufacturing, getting all the materials together in a controlled way and getting it into the chip is most important. Here's why. Imagine the tip of your hair, okay, or a particle of dust. Now, the number of transistors or on-off switches that are packed into a chip today is in billions. The tip of your hair or a speck of dust is bigger than those billions. So when a transistor gets manufactured, it is done in a special clean room. If any of those dust particles or contaminants gets into the chip, it just destroys the chip. That's why these foundries or fabrication facilities are kept in a super clean area so that nothing gets into the manufacturing process. Otherwise, basically the chip will not work or your consumer electronic product will not work. It takes to actually achieve that and make the magic happen at a level that you can't see with the human eye, but it's all done through industrial automation robots. It takes a lot of money to be put into the foundries. So the capital expenditure that goes into foundries to set everything up is billions of dollars. And so they put in billions to make these manufacturing facilities, and then they have to keep the lines full to keep manufacturing to recoup the money back. So Global Foundries is one of those companies which does that. Qualcomm and Intel and Samsung and others, Intel and Samsung have their own foundries. Qualcomm and a bunch of other companies used to have some sort of semi-foundry. They don't have foundries anymore. They don't do manufacturing. They outsource the manufacturing to companies like Global Foundries who manufacture the chips for them. They're called fabless companies because they sell the chips, but the manufacturing is done by companies like Global Foundries. And these are the assets that Global Foundries has today. Global Foundries on July 1st completed the acquisition of IBM Microelectronics, which is again focused on semiconductors. And so the strength of the employee pool has gone up to about 18,000. So what does, ultimately, if you think of what does Global Foundries put out there or manufacture, it's manufacturing something which just looks like this. It's a wafer. So it's something which is round, and it has a bunch of chips molded into it. So the wafers, they look like old long-playing LP records in a way, which has a bunch of chips in them, and those chips get sent to other semiconductor manufacturing companies who take the chip out, put it in some sort of a packaging, and then they deliver it to a Samsung or an Apple or somebody else to either put into your phone or put into your consumer electronic device or otherwise. Now, why is this so important is that all these industries, consumer wireless mobile computing, infrastructure, high-performance computing, et cetera, each of this uses one or more chips at the heart of it. Your car today, I'll choose the car because all of us are very close to our cars, has anywhere from 50 to 300 to 500 chips inside it. Every little control in the car is usually driven by some sort of a chip. When you want to, make the glass go up and down the passenger window, when you go, there's a sound that comes. That's the motorization that happens. So that's why chips are important. They're omnipresent. And these are the other new markets that are coming up as in the world around us, which is, one is the Internet of Things, aerospace, defense, automotive we talked about, and industrial. So this is what a typical chip looks like, and it has all these functions that get tied into the little chip in terms of logic, manufacturing, radio capabilities, voltage management, et cetera, memory. And these are some of the technologies that are called leading edge platforms. So the smaller the number, the smaller is the chip, and the more is the power and capabilities into it. These are called process nodes manufacturing. And I'm going to breeze through this, guys, because this is very involved. The most recent thing that Global Foundries introduced was what's called 22FDX, which is the most advanced way of doing chip manufacturing. So let me ask you guys a question, right? When you think of your phones, or you think of your gadgets, think of your devices, yeah, or your wearables, what are some of the things that you want that thing to do in terms of you want your phone to last a long time, right? Battery, I don't want to recharge it. I want it to download the stuff from the internet really fast. I wanted to do high performance stuff really fast. So power, performance, and you want it to be, cheap at some point, reasonable cost. Power, performance, cost are usually some of the key parameters that go into these manufacturing technologies. So the better the manufacturing technologies that are in the manufacturing that goes into the chipset, the more versatile is the chipset. It brings the cost down. It brings it more capabilities. One of the other things that need to be thought about is when something is sitting idle, when you're not using your phone and it just sits idle, over time the battery drains, right? That's called, in a way, it's called leakage, because a technology is not able to hold the charge for a particular amount of time, and then it kind of gradually leaks out. So that's what Global Foundries is doing, and that leads us to what's the importance of the Internet of Things. So we are here, and I think this is from PricewaterhouseCoopers, and this is interesting. These are the different areas that we are seeing this whole thing known as Internet of Things come about. I read a report today morning that put the number of connected devices in this connected world projected for 2020 to be 14.4 trillion devices. So basically that's more than all of us, more than every living thing on Earth. Okay, you can't even comprehend what that means, but literally everything is connected in some way, shape, or form, and it ultimately leads to some sort of a value return. But a way to look at the IoT is simply devices, network, and services. And underneath all of these are all these controls that need to go in place to make an internet device. And all these controls that lead up to this. This is what your typical chip for an IoT device. So this is an IoT device, which is focused on healthcare. The chip that goes into this, that does all those things that we talked about in the beginning, it has some sort of a smarts, it has a microprocessor of the brain, it has radio controls, it has power management, it has analog to digital conversion. But think of this. The cost to the chipset, the cost for this kind of chipset that go in here are now thought to be sub $1. Not the product, the chipset that goes into it. But look at the capabilities that the chipset needs to entertain. It has to deliver at a cost less than 1/100th of a cell phone, and the size is 1/1000th of a cell phone. So that's the magic that's being weaved into the world around us with semiconductors and IoT. And I'm sure we'll all be connected in some way, shape, or form. And as the gentleman was saying, he was pointing to his head. I know anybody who's seen The Matrix, we may all have a chip one day and be connected. Thank you, guys.